Hello everyone, welcome to the Scope Computer GIS Beginning to Advanced Level series. In this series, we'll start from the beginning and we go to the advanced level concept also. From the next tutorial, we'll discuss about the some practical part, but in this tutorial, we'll discuss about the some theoretical concept. All this concept is very necessary to understand because we are going to use frequently all these concepts. So let's begin. GIS stands for the Geographical Information System. This term was used by the Roger Thompson in 1968 in his book Geographical Information System for the Regional Planning. GIS is a computer-based integrated technology to store the data, edit, manipulate, analyze the data, and create map, report, and chart using any GIS software. There is basic five main components of the GIS. The first is the people, data, software, hardware, method. The people is people like me and you is an example of the people. People is those who give the instruction to the GIS software to run any program. Data, there is several ways to gather the data. The first one, we can directly gather data by going to the field and we can collect the data using doing the survey, or we can download the data from any portal. There is many portal is available to download the satellite imagery. Like in India, there is Google and Bonibi is one example, and the US there is USGS portal is one example downloading the Landsat satellite data. We'll cover all this concept later on. Software is necessary to perform any task. There is many software. We will discuss about some GIS software in this tutorial. Hardware is necessary to run the software, and the method through which we can run the program. GIS also answers the many questions like location, where is it, condition type question, where is it, trend, what has changed since, pattern, what is special pattern exists, modeling, what if. So let's discuss one by one. Where is it? GIS help find places or things on a map like a location, town, or the closest gas station. It's great for making a decision involving multiple factors like finding the perfect vacation spot or ideal land for farming. Where is it? This flip the first question around, helping you to learn about the condition in a specific area. For example, if you are thinking about buying a house, GIS can tell you about the property value, crime rate, and nearby amenities. What has changed? GIS can track changes over the time. By comparing the forest cover from the last 2 decades, we can understand how much the changes happened in the forest cover. It also shows changes in things like a land use or the traffic pattern over the different periods. What pattern and relationship exist is the 4 type of question that GIS answer. By analyzing the spatial data, GIS can uncover pattern and relationship scientifically. What spatial pattern exists? By analyzing the spatial data, GIS can uncover pattern and relationship. It can tell you if the thing like disease outbreak or crime hotspot are scattered or clustered, even analyzing a relationship between the different factors. The last one that GIS answer, what if scenario, is one of the most used question that GIS answer. GIS can use all this data to make a prediction about the future, like estimating the future traffic and delivery time and the changes is going to happen in upcoming decade or the year. GIS can answer a wide range of questions depending on your business or industry. This example should give you a good idea of how GIS could benefit you. There are many applications of GIS. In environmental management, we can consider the last example like a forest cover changes is one kind of application of GIS. Urban planning, nowadays urban planning GIS is the most used softwares. Navigation services, like you all use the Google Map. So basically Google Map is one kind of example of the GIS. Healthcare sector, even in the COVID-19 period, we have seen the how much the GIS is helpful to map the hotspot area of the COVID-19. And land record management. We can consider land record management. In India, there is every state have a own land record web GIS portal so that they can manage the land record using that portal. The next we are covering the Earth space. Space isn't perfectly spherical due to its varied topographical or uneven distribution of the mass. Have you ever noticed that Earth isn't perfect ball? It's because of all the bump and dips on its surface. Scientists call it geoid. So Earth is not like we see in this image. Because of our atmosphere, the planet isn't perfectly round. It's kind of flatter at the top and bulging at the middle. This happened because of the gravity and how Earth is spanned. And here's the cool fact. Sea level isn't the same everywhere. That's because gravity isn't equal all over the Earth. So in some spot the sea might be higher or lower than in other. The gravitational difference affect things like altitude too. Even a notice those number on a plane altimeter. They tell you how high you are above sea level, which changes depending on where you are. So next time you are flying and checking the altimeter, remember it's not just a random number, it's all about how gravity and Earth space work together. Check out this cool map. It shows how high and low different parts of Earth. It's like a colorful, bumpy version of our planet. Knowing about the geoid helps us to make an accurate map and find our way around using GPS. So when you are using your phone to get direction, you can thank the geoid to helping you out. Scientists are always studying on geoid to make better maps and navigation system. They use fancy technology and lot of measurement to get it right. Remember, Earth isn't just a simple ball, it's a bumpy, even changing geoid shape by many things happening over the millions of years. So come out this problem, we have we use the projection system. Map projection is how we represent the Earth curved surface on a flat map. But here is the catch. No single projection perfectly represents the all feature of the Earth. That's why we have different type of map projection, each with its strength and weakness. Some preserve area, other preserve shape, and some maintain the direction. For example, equal area projection. This type of map keep things proportional. So if something in twice as big as something else in a real life, it's look twice as big on the map. There is many more projection like a equidistance projection, azimuthal projection, conformal projection. Now let's talk about the datum. Datum is like a reference point to use to create map. We can also say the datum is a reference point through which measurement is made. There are different datum used around the world. Each has a specific region and purpose. For example, WGS84 is widely used global datum, while MAD 83 is commonly in North America. So in different places there are different type of datums. Datum affect everything from navigation to surveying to creating accurate map. So understanding datum is crucial for anyone working in GIS data. UTM is one kind of projection that we use. So basically we are mainly use the UTM projection because it's very good for the southern Asia part. So we are going to use the UTM projection for our mapping task. Let's discuss about the latitude and longitude. Latitude and longitude are imaginary lines that help us pinpoint any location on the Earth's surface. Latitude measures how from north or south a location is from the equator, while longitude measures how far east or west a location is from the prime meridian. Think of latitude line as a horizontal line stretching from east to west, and longitude line is vertical line stretching from the north to south. Using this line, we can express any location on the Earth with a set of coordinates, like an addressing from the planet. For example, if you are at 40° north latitude and 74° west longitude, you are in the New York City. In every part of the Earth's surface has a unique latitude or longitude. Let's talk about the raster and vector. Raster data is a very simple data structure, and the vector data is a very complex data structure. We can easily edit the vector data, but we cannot easily edit the raster data. About the size, raster data has a very large size. Like if you download any satellite imagery, the size is minimum more than the 1 GB. But in comparison of the vector data, it's a very smaller size. We can easily do the editable tasks in vector data, but doing the editable tasks, raster data is very difficult. Raster data basically associated with the pixel value, which every pixel has some pixel DN value. But in vector data, that is simply a point line and polygons. Let's talk about some software, GIS software. In this lecture series, we will discuss the GIS software. But apart from the GIS software, there is many other GIS software like QGIS, ADARS Imaging, Envy, AutoCAD Map, and Snap. QGIS is open source GIS software which can easily be downloaded and installed in your computer. And ADARS Envy is an image processing software. AutoCAD Map basically a next step to the like AutoCAD drawing. Well, we can do some tasks using the AutoCAD Map easily, which cannot be done using the simple AutoCAD application. Snap basically a software of the European Union to process the Sentinel imagery data. So we are finishing this lecture by the beautiful quote from the Jack Vandermont. This is the founder of the ISRI. ISRI is basically a US-based company that developed the ArcGIS software. So that's it from today's lecture. From the next lecture, we will discuss the practical concept about the GIS. We start from the beginning and we'll go to some analysis tasks also in this lecture series. But thank you for joining in. See you on the next lecture.